All right, so today I just wanted to go over one of the practice FRQs for the 2020 AP Calculus BC exam. And note that these FRQs will be a little longer than you are used to from, say, 2019, 18, or 17, because the exam format has changed this year. So let me start sharing my screen. And so here we're talking about FTC, right? So let's read the question. The continuous function f is defined on the closed interval, x is greater than or equal to -2, less than or equal to 5, and consists of two line segments, right? We see 1, 2, and a quarter circle here, centered at the point 5, 3, as shown in the figure above. The function g is given by g of x is equal to the integral of f of t from -2 to x. So part A says find the average rate of change of g over the interval -2 to 5, right? So when I think about change, I think of g prime, or the slope of g. So what we can do here, instead of thinking about FTC, we think about delta y over delta x. That is what ideally slope is, right? So we can say delta y over delta x is equal to rate of change. So in our case here, we have to think about g of 5 minus g of -2 divided by 5 minus -2, right? So how do we find g of 5? Well, we need to plug it in here to this integral, and we'll get let's find g of 5 over here. G of 5 is equal to the integral from -2 to 5, f of t dt. And so basically this means the area of f of x from this interval. So let's take a look here, -2 to 5. So the area of this section, well, this is basically a triangle, but we see that these two areas cancel out, and this will equal 0. Then over here, we can say it's 0.5, -1. So our area will be 0.5 times -1 times 1/2, right? For the area of a triangle, 1/2 base times height. And we will get 0.5 times -0.5, which is -0.25. So that is this area, -0.25. And then let's look at this section, right? This is a triangle from 0.5 to 2. So this gives us a base of 1.5 and a height of 3. So we can say 1.5 times 3 times 1/2, which gives us 9/4, 2.25. So this gives us an area of 2.25. All right, and here we see a quarter circle. So what we're looking for is the area over here, right, from 2 to 5. So what we need to look at is we have to look at this square area and then subtract the area of the quarter circle. So let's do 3 times 3 is the area of our square minus pi r squared. The pi r squared divided by 4 for the area of the quarter circle. So pi times a radius of 3 squared, so pi times 9 divided by 4, right? Because we have s squared minus pi r squared over 4. And so if we do this, we get 9 minus 9 pi over 4. So to find the area of this whole interval, we just do add all our areas. -0.25 plus 2.25 plus 9 minus 9 pi over 4. And so on the AP exam, we don't need to do decimals, so we can just leave it in this format with pi in it. So we get 2 plus 9, 11 minus 9 pi over 4. That is our value from there for g of 5. 11 minus 9 pi over 4 minus g of -2. So g of -2 is the integral of f of t from -2 to -2, which is 0 because they cancel out. So we'll get minus 0 divided by 7. So here, if we solve this out, we'll get 11/7 minus 9 pi over 28. That is the average rate of change of g on this interval. All right, so now moving on to part 2, we have find the limit of this. So what we would do first case in any limit, we would just plug in x equals -1. So if we do that, we get limit x approaches -1, and I'm going to separate it into 2 parts, numerator and denominator. Right, so limit x approaches -1, f of x squared plus x, and limit x approaches -1, f prime of x minus x, right? So we need f of 1. F of 1 here is 1 minus 1, which gives us 0. And f prime of -1, well, we don't have f prime, we have f. But how do we find f prime, right? So for f prime, it's basically the slope at x equals -1. So the slope here, rise 2 over 2, we'd have a slope of -1 minus -1, which gives us 0, right? So if we put this together, we get 0 over 0, which this is a special case. It's undefined. So in this case, what we would do is we'd say by L'Hopital's rule, we take the derivative of the numerator and the denominator. We can say limit x approaches -1. So taking the derivative of the numerator, we get 2x f prime of x squared plus 1 divided by f double prime of x minus 1, right? So here we're looking at -2 times f prime of 1 plus 1 divided by f double prime of -1 minus 1. Okay, so f prime of 1, right? F prime, we talked about, means the slope at 1. The slope at 1 here is rise of 1, 2, 3, 4, and 2. So a slope of 2, and we're getting -4 plus 1 is -3, divided by f double prime at -1. Well, let's think about it. If f is a linear function, we know that, let's say this part is a linear function. We can say h of x equals negative kx. We know k is -1 in this case, but let's leave it negative kx. And if we take h prime of x, we get negative k, and h double prime of a constant is simply 0. So we can say f double prime of this linear function will be 0 minus 1 will give us -3 over -1, a final answer of 3. All right, and now part C, for the interval -2 to 5, find all values of x for which the graph of g has a point of inflection. So when we think about point of inflection, we immediately think about the second derivative and concavity. So we know that if f double prime of x is greater than 0, we are concave up. And if f double prime of x is less than 0, it will be concave down. And this other case is that if f double prime of x equals 0, we have a POI. This is the condition that we are concerned about in this question. So find the values of x for the function g. So we know that g prime of x by ftc is f of x, which in that case, g double prime of x is equal to f prime of x. So for a point of inflection, we're looking at when g double prime of x equals 0, which also means when f prime of x equals 0. Well, we talked about how f prime of x at any point means the slope of f at any point. So let's see. The slope at f is 0 right here and right here. Over here, we cannot be certain because we only see one side of it. We don't see the rest of that circle. So we can say G has POI at x equals 0 and x equals 2 because f because, well, if we say f, we cannot talk about f, we have to connect it to g. So let's say because f prime of x equals g double prime of x, changes from negative to positive at x equals 0 and positive to negative at x equals 2. And you might be wondering why I'm saying negative to positive instead of decreasing to increasing. Well, we are looking at f prime of x, which the sign of f prime tells us if f is increasing or decreasing. So if f is decreasing here, that means that f prime must be negative. And if f is increasing here, that means f prime is positive. And that is the same thing I did here. All right, and then moving on to the last part of this question, part D. Evaluate the integral from 2 to 4 of f prime of 6 minus 2x dx. Okay, so we know that g of x, g prime of x, is equal to f of x. And, actually, we don't need this in this case. We should just simply integrate. So we'll get f of 6 minus 2x over negative 2. This is undoing our chain rule. So to verify that, let's just take the derivative of this, and we should get f prime of 6 minus 2x, which is exactly what we get. So we're good. Evaluate it from the interval 2 to 4. So what we're doing here is negative f of 6 minus 8 over 2 minus negative f of 2 divided by 2. So we get negative f of negative 2 over 2 plus f of 2. So you see I just combined our denominators here because they're common, and this is what we get. So let's find negative f of negative 2 is 1, negative 1 plus f of 2 is 3 divided by 2 will give us a final answer of 1. All right, so that is our last part to this question. I hope that everything made sense, and thank you.